In today's tutorial, we will try to look into microprocessors and the systems that employs microprocessors. We have already seen the design of flyback converter. If you want to access the playlist, then you can go to the I button, or you can also access the playlist via the link that is provided in the description. Let us first start with the definition of a microprocessor. A microprocessor is a programmable device that takes in the data that is made available to this microprocessor via various input devices. This microprocessor will perform certain arithmetic and logical operations according to the program that is stored in the memory of this microprocessor, and then it will produce desired result. First of all, input devices make certain data available to the microprocessors or the core of the microprocessor. Microprocessor then, according to the program that is written to the memory of these systems, perform certain operations such as summation, subtraction, multiplication or other logical operations on this data, and then it produces a desired result. Now, what do we actually mean by a programmable device? Now, in order to understand about programmable devices, let us first look into a 7805 voltage regulator, which is actually a static device. 7805 is a voltage regulator IC which converts the voltage that is input to the IC to a constant 5 volts. Now, this characteristic of converting input voltage into a constant 5 volt output of this device will remain constant throughout its lifetime. We cannot change this functionality of this integrated circuit. Hence, we can say that 7805 is a device which has a static functionality and its functionality will never change throughout its lifetime. Whereas, it is not the case when it comes to microprocessor systems. The functionality of the microprocessor system can easily be changed based on the instructions and the codes that is written on the memory of these microprocessor systems. Hence, we can say that microprocessor systems are programmable systems such that their functionality can easily be changed by changing the program that is written on the memory of these systems. Now let us look at the fundamental blocks that makes up a microprocessor unit. A microprocessor unit is actually composed of an arithmetic and logical unit which is responsible for performing the arithmetic and logical operations on the data that is made available to the microprocessor core via input devices. But before that, the data that comes in from the input devices are first stored in various registers or the register arrays that are present on the microprocessor unit. There is also a control block which is responsible for controlling and switching external and internal parameters that are available to the microprocessor unit. The memory of the microprocessor unit is actually segregated into read-only memory and random access memory. The instructions for the arithmetic and logical operations that are to be performed on the data actually resides on the memory. Let us look at an example in order to better understand the functioning of the microprocessor unit. Let us consider a case where an analog to digital converter, or simply known as ADC, is interfaced with the microprocessor unit which has certain memory allotted to it. ADC, or analog to digital converter, is responsible for converting the real world signals that are analog in nature to digital signals that are required by the microprocessor unit in order to process them. Hence, we can say that here the ADC will be serving as an input module which will convert the analog data to their digital counterpart, and it will feed the data to the microprocessor unit. Now let us consider a case where the program that is written into the memory of the microprocessor unit is such that if the data that is made available from ADC module to the microprocessor unit, if it is greater than the numerical value 10, then we will have to add two such datas, and the summation will then be stored into a memory location. In this case, first of all, an analog to digital converter will take the data in analog form and will convert it into its digital counterpart. It will then feed the data to the microprocessor unit. This data will be first stored in a register. Then the microprocessor unit will perform certain arithmetic and logical operations on this data, which will be instructed by the program that is written in the memory of the microprocessor unit. Once we get the desired output from the microprocessor unit, then this output will be stored back on the memory of our system. Now let us consider ADC module has presented a data named data1 to the microprocessor unit. Now first of all, the logical part of the arithmetic and logical unit will be engaged and it will compare the presented data named data1 to the numerical value 10, and if this data is greater than this numerical value 10, then it will be stored in a register. Let us say its name is R0 for time being. Now let us say in the second instance what happens that ADC has presented another data named data2. Now again the logical unit of arithmetical and logical unit will be engaged and it will again compare this data2 with the numerical value 10, and if this data is greater than the number 10, then it will again be stored in another register. Let us say its name goes by R1. Now since the microprocessor unit has both the datas that are greater than 10, it will engage the arithmetic unit of ALU and it will add both data1 and data2, and the result will be stored in another register which goes by the name R3. This R3 will be transferred to a specific location on the memory that is interfaced with our microprocessor unit. So with the help of this example, we have seen how various modules of microprocessor unit such as arithmetic logical unit, register arrays, memory and input and output module comes together in order to perform a specific task.